In section 2.4, we're going to learn the mechanics of how to write proofs. We're going to start with algebraic proofs, all right, because we are familiar with algebraic properties, such as our algebraic properties of equality and the distributive property, okay? So when you write these, we are going to be very insistent that you write properties of equality, because there'll be different kinds of properties later. You may abbreviate that to POE. So the addition property of equality would be written as the addition, POE, okay? And then on down the line. So a proof has steps, but then each step has a justification to explain or show why that particular step is valid. Okay, these justifications can be definitions, postulates, or pieces of information that you are given in the problem. All right, this can also be drawn through a figure. All right, so let's look at our first example. Almost always, our first step, and you may want to start numbering these, our first step should be that it is given. If it's a given, that's all you have to say. In step 2, what I did was we added 18 to both sides, okay, of an equation, which means there was an equal sign. All right, so I added on both sides, so this is the addition property of equality. All right, so this just means if you add the same thing to both sides of an equation, then the equation is still true, both sides are still equal. All right, that's essentially what all of these say until we get down into substitution. All right, and we'll get to that one a little bit later. So moving on with our first example, step 3, what I did was I subtracted 3x from both sides. So our justification for that step is subtraction, because I subtracted something from both sides of an equation, so inequality. All right, in our fourth step, what I did was divided both sides by 2, so this is the division property of equality. So saying that if I divide both sides by the same number, then my sides are still equal. In our next example, now we're going to see the distributive property used. All right, so we're going to solve for z and justify each step. Okay, again, you could start numbering these. So this would be step 1, 2, 3, 4, 5, and that will come in handy when we start doing more formal and structured proofs. So now we're just showing the steps of how this happens. All right, so the first one, like I said, is going to be our given. All right, and the next one, all right, in order to get rid of the parentheses, I had to distribute that 3 into both of those terms. So that is the distributive, okay, property. And this one, technically, it's not really a property of equality. It's a property of multiplication over addition. But we're just going to call it a distributive property. That's fine. If you put POE after it, we're not going to take off points, but technically it's just the distributive property. In step 3, all we did was combine like terms. So 55z minus 27z. But this is not subtracting, all right, the same thing from both sides, so it's not the subtraction POE. All right, this is just that we simplified, okay? So you can just write simplified. In step 4, now we added 36 to both sides. So this is the addition property of equality, all right? And then I divided both sides by 28, so that is the division property of equality. All right. So we have some more properties of equality that we can use. These are true for all real numbers, for segment lengths, and angle measures. Okay, so when we have reflexive properties of equality, and again, remember you can abbreviate that to POE, all right? So for any real number, A equals itself. For any segment, all right, AB. All right, remember the segment is indicated by the line over those letters. All right, the length of AB equals the length of AB. And we know that's the length because there's no line above those two endpoints. And for any angle A, the measure of angle A equals the measure of angle A. You can think of the reflexive properties as a reflection, all right? So they're kind of the identity of A, for example, all right? These things are themselves if they were looking in a mirror. For the symmetric properties of inequality, this is to do with symmetry. So I can look at things backwards and forwards. So for real numbers A and B, if A equals B, then B equals A. All right? Same things for segments A and B and C and D. If the length of AB equals the length of CD, I can say that in the other order. All right? Same thing for angle measures for any angles A and B. If the measure of angle A equals the measure of angle B, then I can write it in the other order. And in our transitive properties of equality, this is going to remind you a little bit of the law of syllogism. So if A equals B and B equals C, all right, then we can say that A equals C. Same thing with segment lengths, okay? If the first one equals the second and the second one equals a third, then the first equals the third. Same for angle measures. So let's look at this example, all right? And we're going to start by numbering our steps. And we're going to solve the equation for y, writing the justification for each step. So the first step is given. In the second step, I have just added 4x to both sides, so that is addition, property of equality. And then I divided both sides by 2, or multiplied both sides by 1/2. So actually, in this case, you could actually do either one of those. So I like to say we divided by 2, all right, to undo the multiplication that was with the y. So we'll say division, POE. And then in step 4, all right, we distributed the 1/2, and so that is our distributive property. In our next example, we are given that the length of AB equals the length of CD, which shows up on our first line. Okay, so that's step 1. Our next step, the length of BC equals the length of BC. Well, that is the same on both sides of our equality sign there. So this is going to be a property of equality, and it is a reflexive property of equality. In step 3, we've taken step 1 and we have added BC to both, all right, the length of BC. So that is the addition property of equality. In step 4, we're looking at the diagram, and we see that AB and BC together add to be AC. So we're adding 2 segments, so that is, if you'll recall from chapter 1, the segment addition postulate, okay, using our given diagram, all right, and BD equals BC plus CD, and so that is again the segment addition postulate. And finally, in step 6, all right, we are combining the fact that AC equals AB plus BC and BD equals BC plus CD, and we are substituting those into step 5, and so we then get our statement in step 6 that the length of AC equals the length of BD. And so how we write that, it is that it is substitution, property of equality, and then you're going to want to put into parentheses that that is from step 3, all right, that we substituted steps 4 and 5 into step 3. In our next example, we are given that the measure of angle 1 equals the measure of angle 3, and so that is our first step. In our next step, we have that the measure of angle 2 equals the measure of angle 2. All right, since that's the exact same thing, written the same way on both sides of the equality sign, that is a reflexive property of equality. All right, and now I have added the measure of angle 2 to both sides, so that is the addition property of equality. All right, and now in step 4, it says that the measure of angle 1 plus the measure of angle 2 equals the measure of angle CBD. Okay, so we took two angles, all right, that are adjacent, and they added up to be the total angle. And so if you'll remember, again, from chapter 1, that that is now the angle addition postulate. All right, and then we have, in step 5, we say the measure of angle 3 plus the measure of angle 2 equals the measure of angle EBA. And so again, that is the angle addition postulate. And now we have in statement 4 that the measure of angle 1 plus the measure of angle 2 equals the measure of angle CBD. And so that got substituted there in step 3, and measure of angle 3 plus measure of angle 2 in step 5 equals the measure of angle EBA, and so that is there. And so now we have the substitution property of equality. Remember, we can abbreviate that. And then we want to say that that was substituted into step 3. So the last thing in this section is talking about how we organize a proof. So mathematicians can think about proofs lots of different ways. So just like you can structure writing in different ways, essentially we're coming up with an argument, but instead of writing a paper, we're going to put it into a format. So there are ways you can do a flowchart proof, you can do a paragraph proof where you are just writing words and sentences, but what we're going to use here is a 2-column proof because it's very organized and it's very easy to keep track of what's a statement and what's the justification. All right, so a 2-column proof has 2 columns, all right, and it has numbered statements, all right, and then reasons, which are your justifications, okay? So each statement is either a given or the result of using a definition, postulate, or a theorem, okay? So the reason is the property that you used, whether it was a definition, a postulate, or a theorem, okay? Just like we did in all of our examples above. So let's see what that looks like. We're starting out with a statement, okay? And you notice these are numbered. So statement 1 is that the measure of angle AFD equals the measure of angle AFC. That is listed here as a given. So my reason is just given. In statement 2, it says the measure of angle AFD equals the sum of some other two angles. All right, so AFD is here, and so that is measures 1 and measures 2. Okay, so we're going to fill that in, and we know that because of the angle addition postulate that we can do that. All right, and then in statement 3, the measure of angle AFC is the measure of angle 3 plus the measure of angle 4. All right, and again, that is because of the angle addition postulate. All right, and then in step 4, all right, we have now replaced from step 1, we have substituted in the measure of angle AFD in the first part, and then after the equal sign, we have substituted in for the measure of AFC. So that is the substitution property of equality, and that was from step 1 that we substituted into. All right. Our next statement, statement 5, doesn't come from the diagram. So it comes from up here again in our problem, and it's a given statement that the measure of angle 2 equals the measure of angle 3. So this given is now under my reasons here. Okay? In statement 6, all right, we can see that this is something being substituted into statement 4, but we need to figure out what goes in that blank. All right, so we can sometimes look at the step above, all right, and what was measure of angle 2 is now a blank, and statement 5 says the measure of angle 2 equals the measure of angle 3, so that's likely what we did. Okay, and then when we look ahead to step 7, all right, we've subtracted something off of both sides, and that something had to be the same thing. All right, so it was the measure of angle 3 there, okay? And so we know that our reason for statement number 7 is that I subtracted the same thing from both sides, so that is the subtraction property of equality.